Syndea supports model transform connections between SysML and Simulink. In most of the interfaces we have looked at in other modules, our goal has been to transform a compositional hierarchy, like a SysML block definition diagram, a PLM bill of materials, or a DOORS-NG requirements module. In the case of the Syndea Simulink interface, we are trying to transform both composition and a network of connections, which is a more difficult challenge. The object of this video is to discuss some of the differences between SysML and Simulink models and how to transform a SysML model as displayed in SysML internal block diagrams, or IBDs, to Simulink without problems. Our models have certain elements in common: blocks, ports, and connectors. The purpose of the Syndea Simulink interface is to transform these elements in one tool into the corresponding elements in the other, and to keep them linked so that the two models can be compared and updated as the system evolves. Each tool has other elements that are not in common: value properties and item flows, for example, in SysML, and internal MATLAB code in Simulink, that are ignored by the model transformation. However, even the common elements have some differences, which we examine in this video. We start with our SysML UAV model. Specifically, we have a series of IBDs representing the electrical connections between the aircraft platform and its payload components. In our initial model, a top-level IBD belonging to the UAV block shows these two parts and the connections between them, as well as the input and output communications channels to the outside. A second IBD shows the connections inside the aircraft platform block, which has part properties typed by antenna and avionics subsystem. Avionics has its own internal structure. A third IBD belongs to the payload block, which has part properties typed by radar, thermal camera, and video camera. However, there are some things in this model that do not have an equivalent in Simulink. Applying the Syndea model transform to it as is will create errors and interrupt the process, or leave elements out in Simulink. First, we cannot have a connector crossing the boundary to a nested part directly, as we see here with this connector. To have this connection transform correctly, we need to split it into two connectors, with a delegation port on the avionics block as an intermediary. It's also a problem having a connector run directly to a part property without a port, as in these connections at the domain level in SysML. Simulink has no equivalent. While we're here, it's worth noticing that spaces in block names are not allowed in Simulink. Syndea will replace spaces with the underscore character automatically, but this can still create some issues when the Simulink model is created, when Simulink is trying to compose a multi-level model. Other SysML features inside the payload block that do not have an equivalent in Simulink are item flows on connectors, which are ignored in the Syndea model transform, and nested ports, which cannot be transformed. If we want the model transform to run smoothly, we remove nested ports in favor of a single level of port. Now, Simulink does allow multiple connectors from a single port, as we have done here in SysML, but it does not allow multiple connectors into a single port. So it may be necessary to create additional input ports in a SysML model to avoid this issue. In order for the SysML to Simulink model transform to occur, we need several things available. First, we have to have the Syndea interface for Simulink. Second, we must have MATLAB and Simulink installed and working on our local computer. Third, we have created an empty folder in our local operating directory to receive the Simulink model. And finally, we have created a Syndea network repository connection to our local drive that lets us see the empty folder. Watch the earlier video on creating repository connections to review if necessary. With our modified SysML model prepared, we can launch the Syndea dashboard, go to the Connection Manager, call up the repository network connection to our local file system, expose the empty folder, and drag and drop the top-level block, UAV, into the empty folder. Syndea asks us what we want to do, because the same process could be used to create an Excel workbook or an NX CAD file. We select Generate Simulink Model and click OK. The speed of the transform depends on your computer, the size of the model, and the MATLAB version you use. Recent MATLAB versions communicate with Syndea through an API, while older versions use MATLAB scripts, which is slower. When it is complete, we see all the block elements under the folder heading. We can open the new Simulink model by launching MATLAB and opening this file, or we can do the same directly from the Syndea dashboard by right-clicking on UAV and selecting Open Connected Artifacts. Once MATLAB is started, we can open the UAV block and see its diagram. Unfortunately, Syndea currently does not reproduce the SysML diagram layout, and we see a default diagonal layout. The same is true for the subsystem blocks, like aircraft platform, payload, or avionics. With some manual effort, we can relay out the diagrams more compactly and save the new versions. Now we can see that both the composition and connectivity of the SysML model has been reproduced for this multi-level architecture. One aspect of the mapping between SysML and Simulink is that SysML has a number of different types of ports, Simulink only one. The Syndea model transform maps SysML proxy ports, full ports, and flow ports into Simulink ports. In both tools, ports are typed. In our SysML model, we have used proxy ports, which are typed by interface blocks, which contain one or more flow properties. If a SysML proxy port supports the flow of only one item, i.e. an atomic port typed by an interface block with a single flow property, the corresponding port in Simulink supports only one signal. For example, Port 7 on the avionics block is typed by the interface block camera control, which has one flow property, CamOn: Boolean. The corresponding port in Simulink is named P7 and is typed by Boolean. The names of the interface block and the flow property were not carried over. Now this works for Boolean, integer, and real flow property types in SysML, which become Boolean, integer, and double respectively in Simulink. Otherwise, the Simulink port is not typed. SysML ports can also be non-atomic, i.e. they support multiple flow properties, and Syndea treats them differently. For example, port P1 on the aircraft platform block is typed by the uplink interface block, which contains 7 flow properties. In Simulink, this becomes a bus named uplink. Containing 7 separate signals, each with the same name and data type as the SysML flow properties. Additional videos in this series will discuss how certain Simulink features, such as split buses, map into SysML during the opposite direction model transform, from Simulink to SysML. Others demonstrate transforming SysML behavior models with activity diagrams, comparing and syncing between SysML and Simulink, and using Simulink library blocks to create executable Simulink models from SysML.